Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today, in our 382nd episode, we have a bunch of news, including a new stegosaur and a new alvarezsaurid.
And a bunch of articles about pathologies.
Oh!
Mm-hmm.
Building on last week when we were talking about pathologies with Filippo.
We try to talk about pathologies a lot. They're pretty interesting.
They are. We also have Dinosaur of the Day, Avaceratops, and a fun fact. But before we get into all of that, we want to thank some of our patrons. And this week, we'd like to thank TRX Dinosaurs, Eric, Aaron Rose Emsworthsaurus, Bruce, Nilo Venator, Wouter, Morgan Eklov, Achelosaurus, Trev, and Nicholas.
Thank you so much for being part of our community of dinosaur enthusiasts. And now, jumping into the news, we're going to start off with the new stegosaurs.
Multiple stegosaurs?
Sort of. It's like one new stegosaur, and then there were some indeterminate stegosaur fossils that were described.
Okay, so it's all new material.
Yeah.
Cool.
So this was published in Journal of Vertebrate Paleontology by Dai Hui and others. And I'll start with the new stegosaur, Bashanosaurus primitivus. Now, based on the paleo art, Bashanosaurus looked like other stegosaurs. It walked on all fours, it had plates on the back, spikes on the tail, and shoulder spikes. The genus name, Bashanosaurus, refers to the ancient name of Chongqing, which is where the fossils were found. They're found in the Shashimiao Formation. And the species name, primitivus, refers to it being the, quote, earliest diverging stegosaur.
Diverging, huh?
It's just one of the earliest known stegosaurs.
Okay. I guess diverging from basal thyreophorans.
Yeah. So the quarry where it was found in 2016. They found a wall of dinosaur fossils that was 492 feet or 150 meters long and 26 feet or 8 meters high.
Yeah, we've definitely talked about that before. That is amazing.
Yeah. Also, in the same formation as Bashanosaurus is the stegosaur Huayangosaurus, but they were able to tell that this was a new dinosaur, Bashanosaurus, based on 5 autapomorphies, so 5 unique features. That included the bases of the plates being, quote, strongly convex and transversely thickened, so curved and thick, and they had distinct grooves. Bashanosaurus is estimated to be 9.2 feet or 2.8 meters long, but the authors think that the holotype could be a subadult due to its small size and some lack of fusion in the bones. We'll need more fossils to know for sure, so it's possible it got bigger. The holotype's a partial individual. It includes vertebrae, parts of the shoulder, parts of the left leg, some ribs, 1 plate, and 2 spines. They also found referred specimens, another partial skeleton and a vertebra from a 3rd individual. And they found bones from a 4th individual, part of the skull, a vertebra, a piece of dermal armor, but that individual is unidentified. It's not Bashanosaurus because it doesn't have any of the unique features that they said made Bashanosaurus.
So there's a piece of dermal armor. Did you say there were any actual plates?
The dermal armor is for the unidentified stegosaur, so it's not connected to Bashanosaurus.
But were there any plates, period?
The holotype has a plate and 2 spines.
Ooh, a plate. Okay, cool.
Yeah.
I missed that one in the list of things.
But all in all, they found 3 plates. They're all incomplete, but, between the 3 specimens that are Bashanosaurus.
So 1 plate from the holotype and 2 plates from other Bashanosaurus?
Yes.
Nice.
The plates have a rectangular outline. The base of the spine is missing, but the spine is smooth and tall and slender. So Bashanosaurus lived in the Middle Jurassic in what is now Chongqing, China. Again, the Shashimiao Formation. It's the earliest known stegosaur in Asia, and one of the earliest known stegosaurs in the world, which is how it got its name. And stegosaurs, they've been found on all continents except Antarctica and Australia. This find of Bashanosaurus, the authors say, may show an Asian origin for stegosaurs.
Yeah, maybe. I was just looking through the paper to see if there was a picture of a plate, but I don't think they actually included any pictures of the plates. I was curious because it's pretty small, right? You said it's only about 2.8 meters, 9.2 feet long, and what size plates proportionally there would be on a dinosaur that big. Might have to wait till there's another description.
I think there's a picture of part of a plate in one of the figures. But yeah, it's hard to get a good sense of the size.
They don't have any skeletals or anything with it, do they?
I didn't see any.
Yeah, it seems like a lot of times the papers in JVP are very dense. Like, it's all very specific technical information and not necessarily a lot of drawings or things like that. The reason why I say that is my paper is also from JVP.
Tell me about the alvarosaur.
It's pretty cool. So it was written by Alexander Avarianov and Hans-Dieter Sues, and it's a new alvarezsaurid from Uzbekistan. Alvarosaurids, again, real quick reminder, are those chest-clawed weirdos. I usually think of them now as a cross between like a roadrunner and an armadillo.
Okay.
So they've got the general body plan more or less of a roadrunner, real long legs, skinny, only weigh a couple pounds basically. But they have, rather than having wings or anything, they've got little tiny claws on their chest that are used for digging like how armadillos do. So this new alvarezsaurid probably met that description pretty well.
Mm-hmm.
We don't have a skull, but we got a pretty good portion of the rest of the body. And it builds on the work by these same authors in 2017. Back then they reported what is probably a basal alvarezsaurid from the Turonian, which is about 90 to 94 million years ago, in the Bisecti Formation. And they called that find the oldest parvicursorine alvarezsaurid that had been ever described. And parvicursorines are just a subset of alvarezsaurids. This paper includes more bones from the same stratigraphic unit, so it's the same time and place. And this time there's enough extra material that they named a new genus and species from it. They named it Dzharaonyx eski. Dzharaonyx is after the locality in Uzbekistan, Dzharakuduk, and onyx, which is Greek for claw. So you get Dzharaonyx. If it gets really popular, maybe that A and O will blend together into Dzharaonyx. I'm not sure.
Maybe.
Then eski, or eskai, the species name, is from the Uzbek word meaning old, which I think is a pretty good choice because we've got plenty of species named antiquus, which is Latin for ancient, basically the same idea.
Mixing it up a little.
Yeah. Usually I think it's kind of redundant naming as fossil old, but I don't really think it's been used all that often in the Uzbek form. So still cool. And it's a nice short word.
Mm-hmm.
The bones of Dzharaonyx were all pretty much completely disarticulated. So the holotype had to be just one bone.
Oh, because it's too hard to know what came from which individual.
Yes. And they're pretty confident there were multiple individuals. So what they ended up picking was the right humerus, which is in very good shape, except that it's missing most of the deltopectoral crest, which is kind of an important part, but not the most important part, at least in alvarezsaurids. The author said, quote, "There is currently no evidence for the presence of more than one alvarezsaurid taxon in the Bisecti Formation," end quote.
That makes it easier to name this one genera?
Yes, and it means that all of that other alvarezsaurid material they found in Uzbekistan and described in 2017 would be considered Dzharaonyx, at least for now. So all of those specimens are referred and in the list of referred specimens.
Mm-hmm.
It looks like there's a pretty big mix of individuals. Some bones seem to be from adults, others are from juveniles, so it's sort of all over the place. When you combine it all, we have a pretty good idea of what the body was like, but for a single individual, we don't know all that well because, again, we only have one bone as the holotype that we can tell is definitely from the same individual, other than things that are fused together. They found a good amount of the body, although, again, no skull. They have vertebrae from the back and tail. They also have several partial arm bones, fragments of the hips, foot bones, toe bones, and toe claws. But most importantly, they have a finger claw and some of the hand bones leading up to it.
Ooh, that's good for an alvarezsaur.
Yeah, because that's the most interesting thing is how their hands shrunk down into these giant claw, tiny hand, almost non-existent arm over time. So two of the metacarpals basically meet where the finger protrudes or where the finger starts. The finger bone looks like it meets up with the two bones at once in the hand, basically, although one is more off to the side. So it's sort of supporting the other hand bone right up to where the finger joins. And presumably, this is just my conjecture, that claw would be attached to twice the hand muscles that you would get if there was just one, if there were two claws.
Yeah.
So you could see the argument for why maybe they had that reduction in claws if they can put all of the force into a single big claw rather than spreading it out among 3 claws like most theropods have in their hands. Obviously, you can get more pressure and more force into that one claw. And if you're trying to dig, it's like the difference between trying to dig with a trowel versus a rake or something.
Hmm.
Getting all that pressure on one point could be useful. And that's how armadillos are too. They just have one huge, crazy claw.
So there's a few reasons you're thinking of armadillos.
Yeah. The back vertebrae of Dzharaonyx aren't too far off in proportion to our vertebrae or the vertebrae you see in something like a T-Rex or something like that. They're roughly circular and a little bit longer than they are tall, although there is sort of an unusual bulge on it to articulate with the next vertebra. They're pretty bulged out. There's a fancy paleontological word for it, but I'm not going to bother. The tail vertebrae at the end of the tail are extremely elongated. They're about 3 times as long as they are wide.
Ooh.
So quite long vertebrae probably means it had a pretty long tail to go with it if it's elongating like that. And the humerus is unsurprisingly pretty small. It's only about an inch long, but it's proportionally very wide. So the 2 ends of the humerus are about a third as wide as it is long. So it's pretty, our humerus is nowhere near that, right? Maybe it's a 10th or maybe a 5th, definitely not a third. It's also curved roughly like a parenthesis, which is kind of interesting. I don't know if that was taphonomy. You can never really know for sure when you only have the one bone, but they compared it with some other individuals. So I think they think at least some of that curvature would have been in the living animal. There's also evidence of an extra large muscle attachment site on the ulna where it meets the humerus. And even though the deltopectoral crest wasn't preserved, we can see that it stretched a full 30% the length of the bone.
Oh.
So in general, really big muscle attachment points on this small bone, but the bone is probably mostly small because it was a very small animal. Think about like a compy in that ballpark of little tiny. That's how most of these things were. That's the part that it has in common with an armadillo too. Really small. Overall, it matches really well with the hypothesis that alvarosaurids had good digging potential. We've got that claw that seems like it's got 2 hand bones supporting it. You've got really big muscle attachment points on both the ulna and the humerus for getting that force, like doing epic curls. And the authors also used the humerus to look at comparisons to other alvarosaurids, and they found that it looks like basically it's in between a Patagonicus and a Mononicus. This is important since the humerus is the holotype, so in case some of the bones from those other individuals get split out into new genera in the future, we're going to have to use the humerus for Dzharaonyx, and it'll probably end up being closer to those two. Interestingly, Patagonicus is from Argentina, and it could be from the Turonian, like Dzharaonyx, or it could be from the more recent Cognacian. I never know exactly how to say that. We don't talk about that stage all that often, but it's named after Cognac, France. That's why I'm going with Cognacian.
Makes sense.
So overall, that means that compared to Dzharaonyx, Patagonicus could be a little bit older, the same age, or millions of years younger.
So all the things.
Yeah. Mononicus, on the other hand, is from Mongolia, very far away, much closer to Uzbekistan, but much farther apart in time because we know that Mononicus is definitely much more recent than Dzharaonyx, probably by about 20 million years. So that's what you get if you just look at the humerus. If you include features from all of those referred specimens, you get way more power in your phylogenetic analysis, and then you get Dzharaonyx in a group with Albinicus, Shishionicus, and Coulsonurus. All of those are from Mongolia and China, and they range from about 5 to 20 million years younger than Dzharaonyx, which again would make Dzharaonyx a basal member of that group that they call Parvicursorines. So a pretty important find.
Yeah.
And it's cool to see that they found that many bones.
Yeah. Helps to piece together what that type of dinosaur was like.
Alvarosaurids are some of my favorite weirdos.
Well, sounds like we're learning more and more about them. As promised, we'll get into a lot of pathology papers that have been out fairly recently, starting with a pathological ulna of Amurosaurus ryabininae from the Upper Cretaceous of Far Eastern Russia that was published in an International Journal of Paleobiology by Filippo, who we just interviewed in last week's episode, and others. And you might have seen some of the headlines around this one. There were speculations that this dinosaur hurt itself while mating, but that's just one idea. So the authors, they studied a bone fracture found in the arm of an Amurosaurus hadrosaur, and they described the ulna, that arm bone. And Amurosaurus, it was a lambeosaurine hadrosaur. It lived in the late Cretaceous and was found in the Amur region in Russia. This is from a subadult that was about 16.4 feet or 5 meters long. It was found in a bone bed, only the ulna, but they know from the ulna that it's from Amurosaurus. It's not clear if the injury involved other bones since only the ulna was found, but they did compare the ulna to other uninjured ulnas of other Amurosaurs.
Oh, okay. So we got some good comparisons from healthy individuals.
And ulnas are usually slender and smooth, but this one, from this poor subadult, had a huge swelling at the wrist end. It was a club-shaped end.
Oh, boy. That'd be problematic.
Yes, and forelimb trauma in hadrosaurs, it's not commonly found. Usually we see mostly bone fracture type injuries in dinosaur fossils where there are injuries. So the thinking is that this dinosaur broke its wrist after falling. It was in some kind of upright position, so it possibly fell while mating or reaching for leaves to eat or even just passing the time. But of course the headlines were mostly about the mating idea.
I always just assume they trip. That's how a lot of people break arms and wrists and things like that, is walking along and then tripping and then breaking your fall with your hands.
Yeah, it's really hard to tell from just one bone what happened. Then there was an overgrowth of the bone during the healing process. So the researchers, they did CT scans. They found that the bone was still healing before the hadrosaur died. They also found a misalignment of the fracture parts, so it wasn't healing quite properly.
That's the number one reason it's important to go to the doctor when you break a bone, so that it lines up properly and it heals well.
Yes, dinosaurs didn't have that option.
You don't want to end up like a Amurosaurus.
Since it wasn't healing properly, that meant that even if it did fully heal, the Amurosaurus would have had a deformed wrist. So this hadrosaur, it probably limped, or maybe it walked on 3 of its limbs instead of 4, and that would have made it a lot harder to escape predators.
Oh, so we think Amurosaurus was quadrupedal.
Yes.
Oh, okay. So then the tripping seems less likely because it already has 4 feet on the ground.
Yeah.
And it's a lot harder to trip something with 4 feet.
Yeah. So something happened to knock it off balance. Based on how well this ulna had healed so far, the Amurosaurus probably lived about 4 months before it died. There's no traces of an active infection found in the fracture, so it wasn't the direct cause of death. It's possible that, hadrosaurs, they lived in herds, and maybe that helped this particular individual survive so long, but that's really hard to know for sure.
Yeah, we don't even know if they lived in herds, let alone if that might have helped this specific individual.
Yeah, but it's kind of like, how did it survive so long with this injury that would have made it really vulnerable?
Yeah, that's what I always wonder with these individuals too, where they have a serious injury and we know that it either healed for a long time, like it did in this case, or healed completely. It's like, how weren't there a ton of predators around just looking for the weak thing out there to go eat?
Yeah.
But I guess something, maybe it was just big enough. Although you said it was a subadult, so it wasn't even particularly big, probably.
That's why they're thinking there's more to the story than we know.
Yeah, that's interesting. That's a whole other aspect of how paleopathologies could tell us about dinosaur behavior. If we can start to infer based on which ones survive longer than others and maybe some sort of social interaction. It's really interesting.
Yeah. Just another case that you need more fossils, because then you don't even know how far the injury spread. Right now, you just have the ulna.
Yeah. Yeah.
So our next pathology paper has to do with looking at the jaw of T-Rex Tristanotto for pathologies.
Is Tristanotto the species, the
nickname? Yeah. It's named after 2 people.
Oh, Tristan Otto.
Yeah.
Gotcha.
This was published in Radiological Society of North America by Charlie Ham and others. They looked at the jaw of Tristanotto, which was found Tristanotto was found in 2010 in the Hell Creek Formation, and that skeleton includes 170 bones, including 50 skull bones. It was sold to an investment banker who loaned it to the Natural History Museum in Berlin, Germany. So I think there's been a lot of researchers who've been able to access it.
Cool.
Now, they found that Tristan had a bone infection in the lower left jaw. The team used, it's called dual energy computed tomography. It's a type of CT scan, also known as DECT. And then they made a 3D image. And DECT, it looks at X-rays in two different energy levels, and then it'll give information about tissue composition and disease processes.
Or in this case, rock composition.
Right. Also the chemical composition of bones.
Oh, cool.
So it's the first time, at least they said to this team's knowledge, that this has been used. There have been CT scans of Sue, the T-Rex, that found chronic osteomyelitis, a bone infection, but they didn't specifically use DECT. What they did was they scanned a lumpy mass on the jaw that went into the root of one of the teeth, and they found that this mass had a high concentration of the element fluorine. And that probably means that that area of the bone was less dense than the surrounding tissues when Tristan Otto died. And during fossilization, groundwater with fluorine would go into the bones and the areas that were less dense, and that was probably because there was an infection, so then the infected area got more fluorine.
Gotcha. Okay, so it didn't fluoridate while it was alive.
Yeah.
It got infected while it was alive, and that left a hole, basically, for water to get into.
Yes.
Interesting.
So Tristan Otto had tumefactive osteomyelitis, which is a bone infection tumor.
Tumefactive? I don't think we've heard that word before.
No, I had to look that one up. Which sounds awful, but it's cool that we can figure these things out.
Yeah.
The team's also planning to scan more fossils from the Natural History Museum in Berlin and improve on this DECT technique so it can be used on more fossils in other museums. They got to work on, minimizing artifacts and improving image quality. But this technique can help look at the chemical composition of fossils without damaging them.
Nice. Whenever you can do non-destructive tests, non-invasive tests, that is better because people are a lot more willing to let you do that with their fossils than if you have to start cutting them open.
Yes. Especially if the non-destructive tests can also give you more information than other kinds of tests.
Yeah.
So the next paper on pathology, it's about 4 pathologies found in sauropod ribs from Chongqing, China. This was published in an international journal of paleobiology by Chao Tan and others. They said that not many dinosaur pathologies have been reported from China. Only 5 before, from Lufungosaurus, Gigantspinosaurus, Yangchuansaurus, and Psittacosaurids. But I guess only 5, and then this paper describes 4 pathologies, so you've almost doubled the number
of
pathologies.
That's the total number of pathologies, not the number of animals with pathologies.
Yeah. The sauropod bones that they studied, they were from sauropods that lived in the Middle Jurassic, and all the ribs were found in the same quarry, the Shashimiao Formation. These bones, they were isolated, and they probably came from a few individuals, and they found these abnormal enlargements on the ribs. They're thinking it probably came from Omesaurus or Shunosaurus. So the researchers, they did CT scans, and they analyzed the features, and they did 3D reconstructions. They found one of the ribs had a traumatic fracture and was in the late stages of healing. There were 3 bone calluses, which is bony cartilage material that forms a bridge across a bone fracture while it's healing. 2 of the ribs, which they think probably came from the same individual based on them being found close together in the same quarry, had infections that caused osteomyelitis, that bone infection, and those spread. And it could be that some sort of trauma led to the infection. And the last rib had Osteopetrosis. That's a disorder that causes bones to grow abnormally and become too dense, which makes them easier to break. Poor sauropods.
That is a lot of problems. I've heard of osteoporosis before, but not osteopetrosis.
I didn't think it would be a problem if your bones were too dense in terms of making it easier to break.
Yeah, that's weird, huh? I guess they need some flexibility and things like that.
Yeah.
Especially a rib.
Ooh. Yeah, these poor sauropods. At least it was multiple individuals, probably.
I guess that's a good thing.
Trying to find silver linings here.
Yeah.
Now, next, this isn't exactly a pathology, but it's about studying what happened to a particular skeleton after it died. And the skeleton in question is the Brex specimen. Researchers wanted to figure out why soft tissue was preserved with it. So this was published in Biology by Paul Ullman and others. Brex was found in the Hell Creek Formation in 2000. They have 37% of the skeleton. That includes most of the skull. You can see a cast at the Museum of the Rockies. I'm pretty sure we saw that cast. Pretty sure we have pictures of that cast.
Probably. We have a lot of pictures of T-Rex skulls from Museum of the Rockies. B-Rex is probably in the mix.
And there was soft tissue found in the right femur and tibiae. So the authors, they looked at the taphonomic and geochemical history of Brex to figure out what happened to Brex after it died. They compared Brex to Edmontosaurus bones that have also been found with soft tissue that was found in the Standing Rock Hadrosaur site in South Dakota. And they found that Brex was buried in coarse sandstone. Brex bones were found spatially isolated, so they weren't stacked on top of each other. There were also no big signs of weathering or anything being scraped away. These bones were fossilized while interacting with some potentially brackish groundwater. Compared to other recent studies, bones that fossilize like this, there's oxygen in early diagenetic environments, the physical and chemical changes in the sediments, that don't have much exposure to fluids. It can go into porous areas of soil and rock, makes it more likely that the fossils preserve soft tissue. They took a sample from the right femur, and they used mass spectrometry methods, measured the mass to charge ratio of ions, and they also analyzed trace elements, like rare earth elements such as uranium, scandium, and they found low levels of trace elements in the bone. Now, based on stratigraphy, Brex was buried in an active channel in a lush, low-elevation environment within 5 kilometers of the western interior Cretaceous Seaway.
Ooh, that is close.
Yeah.
I can see why they thought it was probably brackish.
Yeah. It's unclear how Brex died, but it probably died slightly upstream from where it was buried. And then, it died and the body was moved downstream. It was carried by a river or stream. And then it decomposed mostly underwater. It probably sank to the floor in a brackish channel, and then the skin and muscle continued to decay. The femur, they said, was, quote, only modestly chemically altered for its age, end quote, which might be why soft tissue was preserved. They're saying for future research, it would help to look at fossils from other localities from this point of view. These kinds of methods and how things were buried and decomposed and everything.
Yeah, that's one specimen I'd like to see in person, to see just if you can tell from the naked eye that there's any soft tissue there, or if you can only see it under a microscope.
My eyes are not trained enough to know unless someone points out to me.
Yeah. I mean, sometimes soft tissue just means that like there's remnants of an old blood vessel buried in the bone, which is really useful and interesting, but it's not that striking. Whereas other times soft tissue preservation is like a mummified skin coating kind of thing, like we get around hadrosaurs sometimes. I don't think this was that much. It sounds like it's internal in the bone, so it's probably blood vessels.
Yeah, I think you're right. I think for Brex, it's blood vessels and structures.
There's a lot of those in bones, at least before they fossilize, and I guess sometimes after they fossilize.
Yeah. We have a few other news items that aren't quite as dense.
Pop culture type items?
Yeah. I'll start with, and maybe some people have seen this we posted this on our social media accounts, a photographer that took some really fun photos of squirrels playing with dinosaur toys. Nikki Coleman, a photographer from Belgium, has been photographing the red squirrel for the last 6 years. He spent something like 3,200 hours doing this.
That's a lot of time looking at squirrels.
Oh, they're great pictures. And he's usually around 10 feet or 3 meters away in camouflage, so he doesn't scare the squirrels.
I had assumed that they were triggered remotely. I didn't realize that he actually was there.
Yeah. And he says the squirrels are used to him now. And he played with dinosaurs as a kid, and he loved Jurassic Park, so he wanted to bring the squirrels and dinosaurs together as a sort of tribute. I guess it took 3 days for the squirrels to get used to the dinosaur toys. And one way he did it was like he put a walnut in the dinosaurs' mouths and then the squirrels would come and grab it. You can see in some of the pictures the squirrels coming for the walnut and interacting with a T-Rex toy.
Yeah. I would say saying that they were playing with the toys is a generous interpretation.
Yeah.
More like taking food off of the toys.
Yes, he does use food in each setup, but sometimes the food's hidden, so you don't see it in all the pictures. And then it looks more playful.
But really, the squirrels are there for the food, not for the dinosaur toys.
It's still really cute photos. Like, one of them looks like the squirrel's hugging the dinosaur, or another one's, like, biting to get to the walnut, or maybe it's just curiously looking around. I guess it's probably looking for the food. Very enjoyable pictures. We also have a couple new games or game updates. Starting with Capcom has a new game about fighting dinosaurs called Exoprimal. The game takes place in 2043, and these mysterious vortexes have opened up and out come armies of dinosaurs. You have to wear an exosuit to fight the dinosaurs. It's a multiplayer co-op game, and you can change the suits to match the different dinosaurs. It looks like you mostly fight theropods. I could see T-Rex and maybe a velociraptor, although it looked kind of like a hybrid. Had extra long arms and glowy red eyes.
Interesting. Yeah, that's pretty typical of dinosaur games.
Yeah.
Extra ferocious theropods.
It's true.
As killing machines. But I assume that you play as a human?
Yes, you play as a human. That's why you have to wear the suits, the special suits.
Gotcha. Because otherwise they'll just chew right through you.
Mm-hmm. And then I think depending what suit you're wearing, you have more strength in some areas than others.
Yeah.
As next game, I think you'll like the sound of it, Garrett. Skyhook Games has a Dino Safari DLC for mowing the lawn in Dino Safari Park.
Why would I like that?
It reminds me a bit of that truck simulator game that you play sometimes.
Well, I mean, I like the truck simulator game because it's relaxing.
Yeah.
And it's sort of like a racing game, and I really like racing games. If I want to mow the lawn, I'll just go outside and mow the lawn.
This is a really popular DLC. I think other people find it just as relaxing.
Okay, maybe they don't have lawns to mow. I don't have a truck to drive.
Well, you're in multiple locations like T-Rex Paddock, Cretaceous Canyon, Herbivore Valley, the Raptor Enclosure, so you're mowing the lawn alongside dinosaurs.
Are you on a riding lawnmower? Those are a little more fun than the push mower that we have.
Yeah, I think you might be. It's very popular.
I was very excited the first time I got to ride a riding lawnmower when I was like 12. Visiting my uncle in his huge fields that needed mowing, but
all right,
it gets old pretty quick.
Maybe this game isn't your cup of tea, but it is for a lot of people, it sounds like.
I think you just wanted to make fun of my truck simulator game.
I wasn't making fun.
You can go to Vernal in American Truck Simulator and see all the dinosaur sculptures. It's pretty cool. Just saying.
I said nothing bad or disparaging about either game.
Okay. Let the record state.
Yeah.
And now we're going to take a quick sponsor break, but when we get back, we'll be getting into our dinosaur of the day, Avaceratops.
And now onto our dinosaur of the day, Avaceratops, which was a request from PaleoMike716 via our Patreon and Discord, so thanks. Avaceratops was a ceratopsian that lived in the late Cretaceous in what is now Montana in the US, in the Judith River Formation. It looked like other ceratopsians, walked on all four legs, it had a bulky body and a long tail, and a beak and a frill on its head. It had a short fan-shaped thrill.
Yeah, I always think it looks sort of young and like juvenile because it's got a shorter frill.
Yeah, I could see that. It was also small and herbivorous. Originally, it was estimated to be 7.5 feet or 2.3 meters long. And then in 2010, Gregory Paul estimated it to be 13 feet or 4 meters long and weigh 1 ton.
Still way smaller than a lot of the other ceratopsians rocking around in the late Cretaceous Montana.
They're rocking, huh?
Mm-hmm. They look like rockabillys with their horns.
The type species is Avaceratops lamersi. It was described in 1986 by Peter Dodson. The fossils were found in 1981 by fossil dealer Eddie Cole on Careless Creek Ranch, which was owned by Arthur Lammers. That's how you get the species name. The fossils were scattered on a prehistoric stream bed. It was probably buried after its body was swept downstream by a current. Peter Dodson looked at the fossils in Cole's fossil shop when he was visiting in 1982, and then they fully excavated the dinosaur in 1984. Avaceratops was the first ceratopsid named since Pachyrhinosaurus, which was named back in 1950.
And this one was
86.
Oh, wow.
Yeah.
36 years of no ceratopsians named?
I guess.
Ceratopsid.
Ceratopsids, yeah.
Okay, that's a subset.
Oh, and the genus name Avaceratops is in honor of Ava Cole, Eddie Cole's wife. In 1990, George Olszewski updated the name to Avaceratops lamersorum, making it plural, since the name referred to a few people, but Dodson objected. He said a singular name can also refer to a single family name.
Huh. I mean, I guess it can, but I think if you said, like, the Smith, you're talking about one person versus the Smiths would be a group of people.
Yeah, I could see your point, but
I think it works, though. I mean, it's still Latinized properly.
Yeah.
If you just make it Lammersi.
Yeah. In 1990, Thomas Lehman referred Avaceratops to Monoclonius, but that was not accepted. The holotype of Avaceratops includes a partial skeleton with the lower skull, vertebrae, shoulder girdle, and most of the forelimbs and hind limbs.
Oh, wow.
Yeah, and the skeleton's probably a juvenile or subadult.
Okay, that might be part of why it's so small.
Yeah. Pankowski and Dodson described a second skull in 1999 of a larger specimen. But a 2010 study by Michael Ryan and others found, quote, it will never be possible to definitively assign, end quote, that skull to Avaceratops because the holotype of Avaceratops is a juvenile and doesn't have unique characters. And the second skull, which is presumably of an adult, looks too different. So it's hard to know if they're related without having some kind of growth series to compare.
Gotcha. So there were unique things about Avaceratops, but not in the skull, I guess?
Well, they said that even though Avaceratops didn't have any unique characters, quote, the specimen cannot be attributed to any other known centrosaurine, and so the genus cannot be synonymized or declared a nomum dubium, end quote.
I see. So it doesn't have autapomorphies, but it's got enough of a mosaic in that place that it seems unique.
Yeah. Avaceratops is a sister taxon to Nasutoceratops. And other dinosaurs that lived around the same time and place include the ceratopsid Medusaceratops and the hadrosaur Probrachylophosaurus. And our fun fact for the day. How do you feel about that, Garrett?
I'm okay with it. You do good fun facts.
Thanks. So even in the Cretaceous, dinosaurs were sometimes the meals of other animals.
That is a fact.
Yes.
You mean other non-dinosaurs?
Yes, that's what I mean, other non-dinosaurs. There was a paper published by Matt White and others in Gondwana Research called Abdominal Contents Reveal Cretaceous Crocodiliforms Ate Dinosaurs. And they found a juvenile ornithopod in the gut contents of a crocodiliform. You know how I love gut contents.
Yeah.
So the authors described a new crocodilian from Australia. It was found in the Winton Formation. They named that one Confractosuchus soroctonos. The genus name means broken lizard because it was found in a shattered concretion. And the species name means killer, and that refers to the gut contents. Confractosuchus was estimated to be about 6.5 feet to 8.2 feet or 2 to 2.5 meters long. It lived sometime between 92.5 to 104 million years ago. And the last thing that this animal ate was a young dinosaur.
I mean, that's a good point. Young animals of any type are often the prey of larger predators of every type.
Yes. That's why you gotta grow fast.
Yep.
Now, preserved gut contents in crocodiliforms are rare. They found that Confractosuchus was a probably macrogeneralist feeder, or at least a generalist feeder, not a dinosaur specialist. And that means, as a macrogeneralist, it could go for prey larger than itself.
Oh, wow.
Yeah. And it was probably just an opportunistic feeder, like most animals. The team did neutron tomography and 3D modeling. They found vertebrae, part of the leg, and other elements that couldn't be identified, but probably came from the same individual based on its relative size and non-repeating elements. I'm talking about the dinosaur now that was partially digested. And they could tell it was an ornithopod based on the femur. There was a lack of fusion in these elements, so they think it was a juvenile. Now, vertebrae from each of the main regions, the dorsal, sacral, caudal, they were articulated to associated, quote, suggesting connective tissues were still intact at the time that its consumer died.
Hmm.
So it was a recent meal before this crocodiliform died. The bones of the ornithopod were partially articulated and there was no acid etching, so it wasn't, quote unquote, significantly digested.
Oh, interesting. Sometimes when the bones aren't acid etched, people will say, well, did it actually get eaten or was it just in the vicinity of this other animal and it's sort of the two skeletons lined up when they got buried, so it looks like it got eaten?
I see. Well, in this case, they're pretty sure it was eaten. It's possible the ornithopod was scavenged, but since it was small compared to the Confractosuchus, it could be that the crocodiliform ambushed the dinosaur.
Yeah. Yeah. Ambushing tiny babies is usually not that difficult. Like you said, you got to grow quickly.
Yeah. What's really interesting is these ornithopod bones that were found inside the crocodiliform are the first ornithopod bones found in the Winton Formation, and they might represent a new dinosaur taxon. Because before, we only knew about ornithopods from one shed tooth and footprints.
That's really funny. That reminds me of I think it was a mammal or something that was named in a coprolite.
Oh, yeah.
It's just sometimes it's a good way to preserve these little bones because all the little animals or a lot of the little animals get eaten, so they don't fossilize all that well often.
You've got to get buried at just the right time for that, though.
Yeah.
Now, the tibia of the ornithopod, it's similar in appearance to the South American ornithopod Notohypsilophodon. It's a gracile tibia. It might mean it's a new dinosaur taxon, or maybe it's gracile because it's a juvenile dinosaur. There's no clear autapomorphies or distinct features, so they did not name the ornithopod.
Oh, that's too bad. It would have been nice if it was like that little mammal or whatever it was that got named in the coprolite.
Yeah. Maybe someday.
And that wraps up this episode of I Know Dino. Thank you for listening. If you want to see the links to all these papers about the different taphonomy and our two new dinosaurs, head over to iknowdino.com and go to episode 382, and all the links will be there. Thanks again, and until next time.